鬼岛之音
Ghost Island Media.
亲爱的市民朋友，大家好！环保局推出施违规小广告冒好礼活动，大家快来做环保。
Hi, this is Waste Not Why Not, a sustainability podcast from Ghost Island Media. I'm Nature Nate, a sustainability consultant based in Taiwan, working on energy, ocean, and waste. Today we continue our new season. Oh, and be sure to follow our Twitter account at WasteNotPod. We give regular updates to news and happenings in sustainability that aren't just related to these episodes. We talk about pangolins, the Milky Sea, green libraries, a lot of good stuff. And today on the show, we're going to talk about electric vehicles. Zoom, zoom. That's what EVs sound like, right? In episode 5 of Waste Not Why Not, you heard me call up my automotive journalist father, Mark Maynard, and found out that I was a test ride baby in the first generation of the modern electric vehicle, the EV1 by General Motors. That was 1996, so I guess I was a bit bigger than a baby, but in 1996, engineers all around the US and the world were trying to figure out how to make vehicles do more, go faster, carry more weight, even go to Mars. Our guest today was an engineering student in Michigan in the late 1990s. He was one of the many really smart people who were trying to figure all this stuff out.
I saw a fun two-seat electric sports car. You know, who doesn't want to work on a fun product? Being environmentally conscious has been a theme of my career, but it's not been the driver. It's been about better products.
That's Azizi Tucker, a tinkerer, an engineer, a designer of vehicles. Azizi raced mountain bikes competitively as a youth, but his introduction to cars came when he was racing against professional race car drivers and designers during his college years. That's right, he raced against people who designed the cars he was driving. Then he worked at NASA and then left because he thought building for aerospace was, get this, too slow. Rockets in space, slow-paced. Who would have thought? And that's when he joined a little-known electric vehicle startup that was shortly afterwards purchased by some guy named Elon. And that's when Azizi Tucker went all electric, all the while trying to figure out speed. While going fast was always his thing, at this point, electric cars became his ride. He started building electric supercars with an EV company he co-founded in Taiwan. And today he's now building the coolest and the most quiet dirt bikes. Today we're going to find out just how diverse the field of electric vehicles really is. And we're going to see how Azizi's continued to learn and innovate and make breakthroughs in speed throughout his career. Let's get the show started. Vroom vroom, zoom zoom, zzz. Play the tape. Let's just start at the beginning. So I'm also a Californian. We have two Californians in the studio today. Where did you grow up, and did that influence your interest in making things?
Where I was born absolutely kind of shaped me. I was born in Oakland, California, in the San Francisco Bay Area. I grew up with parents who did outdoor activities. Some of my earliest activities were riding my bike to keep up with my parents while they went for jogs in the hills. And that riding my bike actually transitioned into racing mountain bikes. I was racing bikes and doing a few of the national championship races in the early 90s. Through that experience, I joined a Young Entrepreneurs program at UC Berkeley when I was in junior high school. That program taught us how to start our own businesses.
Wow, I didn't even really know what money was in high school.
Yeah. I mean, and this was like 7th, 8th grade, and so we were doing business plans and all this. At the end of the Young Entrepreneurs program, we had to do a pitch to investors. And I did a pitch to design some bicycles. I had no idea how difficult it was going to be, but the investors gave me some money. And that allowed me to buy some computer-aided design software. And from there, I started trying to design this bicycle that I wanted to make, starting when I was maybe 14.
Wow. So you've been designing bikes from the get-go, basically.
I don't really want to say designing, because what I tried to design, and I say try, I laugh at that design now, and I never was able to finish it. But what I did is also go to community college while I was in high school. And I learned manufacturing. I got a scholarship from the community college to buy some manufacturing equipment and was able to buy a very small CNC metal cutting machine. And so that allowed me to start creating my designs.
Wow.
The people I was racing against had more expensive bikes than my parents would buy me. And I was thinking maybe I can just design a bike that's better than the best bikes on the market. I was fortunate enough to meet Charlie Cunningham, who's one of the inventors of mountain bikes, so I could see the way he worked. took a tour of his shop when I was in high school. And so I was able to see the equipment he was using. And I was like, if this guy can do it, maybe I can do this.
Pause that tape. Did you catch that name? Charlie Cunningham, the man who inspired a young Azizi. If he could do it, then I could too. Charlie Cunningham was a mountain bike racer and inventor. It's said that his attention to biking had a lot to do with environmental reasons. He was inducted into the Mountain Bike Hall of Fame in 1988, and that's where we found this quote. Mountain bikes are a perfect way to combine technology and nature in a way that is friendly to life. They can be an alternative to the abuse of technology that is so widespread in our world today. The more one uses the bicycle, especially in a natural environment, the more sympathetic and understanding one becomes of oneself and the planet. I like this Charlie guy. Okay, let's resume the tape. Let's head to the moment Azizi went to college, where he will now get into cars.
So, I went to University of Michigan starting in 1994. The experience was really, really good for me in that by now I was doing some amateur car racing also.
Okay.
And unbeknownst to me, the people I was racing against were all industry guys. I didn't know this at the time. They're just regular guys.
They were like, oh, I design cars, by the way.
Exactly.
Okay.
Or I race cars at a professional level and I just do this for fun on the weekends. Or these
Stiff
kind of
competition.
things. Yeah, exactly. Yeah, and there was one of the racers I raced against actually designed the car I was racing. So he was someone I never beat.
That makes sense. You're racing with the true masters.
Yep. But, University of Michigan, with a strong engineering department, the connections to the automotive industry was really where I wanted to be. But through the hobby of racing, I started meeting people. And interestingly, there was a Chrysler project to do a hybrid hydrogen power car. Very early. I think this was maybe 95.
Wow.
It was a race car that they built one prototype, and so I was able to talk to one of the engineers who worked on this. I didn't think much of it, but it obviously was interesting for me to know that this was possible, particularly the speed that was possible later in my career. So it planted seeds. That's really what it did.
Starting to experiment with different technologies.
Exactly. But everything was gasoline cars. There were no EVs at that time. I don't think the EV1 was even out at that time when I was in college. So everything, we were studying was traditional combustion engines and mechanical engineering.
So you're at the University of Michigan, you're working with sort of the best automobile minds, but then you left school.
Yeah, so I actually left school twice. The first time was not my choice. I was kind of on academic probation. I was struggling with some classes. I actually have a learning disability that's made part of my school quite easy, but getting some of the basics down was challenging. When I left, I actually started a small business, and I was making car parts. And I was making the parts I needed for my race car so I could be faster since I couldn't afford to buy them.
Okay, so you were selling car parts like for amateur racing?
Yeah, I was actually working at a manufacturing company, and I made an agreement with the owner that I could use the whole company in the night shift.
Wow.
So I would design and kind of make these parts, race with them. If they worked well, I'd throw them up on my website, sell them, and I'd have some cash. So, that was the young man mindset.
And how old were you when you were doing this?
This was probably 22, 23. I was not a particularly good businessman. I would typically there's a race coming up next month. Let me design some parts today, see if I can get them for sale, and go from there.
And then this didn't work out?
So actually what happened is I reapplied to get back into college. The dean of the School of Engineering was really impressed with the products I was making. Was a little surprised that I was engineering and manufacturing products and doing product testing and all these things during what should have been my junior year.
Oh, yeah, you're supposed to learn that in school.
Yeah, exactly. And so I came back to college, but after about a year, I had to make a choice between growing the business, which was doing pretty well, and continuing with class. I just realized the two weren't going to work out, being able to do both. And so I ended up focusing on the business, grew it a bit, and ran that for about a year or so, maybe 2 years.
Okay, so you're racing cars, you're going to school for automotive design, and then what's kind of your first sort of job?
I got a job at a local small manufacturing company, Merino Engineering. And that was my first time to really see professional, kind of low, medium volume manufacturing. We were a supplier to like GM, Ford, and Chrysler, building engine blocks, cylinder heads, and even some complete engines. And so it was interesting for me to see kind of the opposite side of what I was learning, which is products. I'm learning how to design, but now I'm actually making the designs that other engineers have created. And the boss, Mike Marino, really gave me a huge advantage. He gave me a place to work, but then he gave me a place for my business to grow. And so, I'm really grateful for that opportunity. And he was a great mentor. I learned a huge amount from him during the period we worked together for about 3 years. And I made a decision probably in '99 to leave the automotive industry and join the aerospace industry. And so I ended up moving to Washington, D.C. and working at NASA Goddard Space Flight Center, doing thermal systems and kind of frames and structures for satellites.
So you went from designing vehicles and cars on land on Earth to NASA, where you're designing not necessarily cars, but technology vehicles in space. What was that like? What was it like starting at NASA?
Disorienting. So much of my engineering background was not applicable due to the high levels of quality.
So that was really, literally world class, because you're designing things at the Earth standard for usage in outer space.
Absolutely. And, I thought I knew engineering well from working in the automotive industry, and it was almost like a blank sheet. Something as simple as a nut and bolt was unrecognizable from my previous job. Level of rigor and just the attention to detail was so high.
Because if something fails in space, it's gone.
Exactly. So it was really a reset. And I was really, really fortunate to be in that environment because coming from my previous environment, I knew production, I knew how to make things quickly and in high volume, but I didn't understand how to do things at a world-class level. And this was absolutely world-class.
Was there a favorite project you had when you worked at NASA?
By far, my favorite project was one of the last projects I worked on, which was called the Solar Dynamics Observatory. It was one of the bigger projects I worked on. Typically, people don't work on a single project, and we do sections of different projects. But this one I did a fairly large structure, and it's a camera system, cameras and sensor systems that study the sun. So if you Google SDO from NASA, you can see the images that it's producing now. So that was definitely my favorite project. Oh, I've worked on something that's probably on Mars, but I'm not sure. Yeah. We didn't get a lot of information about where it was going.
It's like a secret, or?
When you work in aerospace, there's projects that are classified, and then there's projects where they just don't tell you much information.
Oh.
And so we worked on a project that did some digging on another planet, but don't know when it left, don't know when it launched, don't know if it arrived.
Wow. Yeah, once you're in the rocket scientist, spectrum category, put something into space.
I mean, that's really real talk. It really does give you perspective about difficult challenges. And so building something like an electric car is pretty easy after you do aerospace stuff. It's just solving a bunch of problems in a row.
All right, let's take a break here. We've been talking to Azizi Tucker on his path from dirt bikes to cars to building things that may or may not be on Mars right now. When we come back, we'll find out why Azizi Tucker left NASA and how he ended up at Tesla, taking close to 100 trips a year to Asia.
Hey guys, it's Emily Waiwu here. I produce Waste Not, Why Not. I want to give a big shout out to the American Institute in Taiwan, AIT, who's supporting this mini season you're now listening to. AIT, in addition to focusing on climate-related initiatives, is also very supportive of Taiwanese startups and entrepreneurship. And they take sustainability quite seriously. Their new campus in Taipei is LEED Silver certified. And we have a whole full-length bonus video interview talking to the man who takes care of this green building at AIT. So, after today's episode, head over to Ghost Island Media on YouTube and to the playlist Waste Not, Why Not. Now, back to Nate.
Welcome back to Waste Not, Why Not. We've been talking to entrepreneur Azizi Tucker, a tinkerer, an engineer, a designer of vehicles. Azizi raced mountain bikes competitively as a youth, and when he was studying engineering in college, he raced cars against professionals. Now at NASA, while the drive for absolute quality was something he admired, the careful development process was something that Azizi never got used to.
Something as simple as screwing two things together could take 2 or 3 weeks of planning, testing, checking. And so I was getting impatient. I was used to a much, much higher kind of rate of pace. And while I found the work there really inspirational, the other part is I couldn't share things.
Right. Yeah. Some secrecy involved.
Yeah. Obviously, things like that. No one knew what we were working on. We weren't allowed to bring cell phones into the building. And so I really kind of missed also being able to share what I was doing. And as innovative as space is, there's actually a lot of blocks to innovation because the level of risk is so high. So a lot of the new projects, we would have to find components that had space heritage, meaning things that had been in space before. There's a huge number of barriers to bring new technology into space at that time through NASA, obviously. Maybe some of the newer organizations are a little more agile, but due to the risk aversion, it was quite conservative at the same time as being innovative.
And I think that might be shocking to some people. This is what some people, they go to camps, they go to trainings their whole life. They just want to work on NASA and go to space. And you're like, maybe not for me. What are you thinking about at that time? What are you looking for your next career move?
I moved back to the San Francisco Bay Area, and I started looking for jobs there. I saw an ad in the newspaper for a job at a company called Tesla Motors. I think their website had been up a month or something at this point. So very few people knew about the company. So I knew very little about them. None of my friends in the car industry knew anything about them. But I was intrigued by the car. I saw a sports car, a fun 2-seat electric sports car, which looked exciting. With my love of racing, I was still doing amateur racing after all these years. So working at a company building an electric sports car was a dream job for me. This would be 2006, 2007. So when I joined Tesla, the company had less than 100 people. Elon Musk was not the CEO.
People forget that.
Yeah, people forget that.
So you went to Tesla because it was cool, not because it was about stopping climate change or saving the world.
Climate change or saving the world was the furthest thing from my mind. It actually still is not something that at the forefront of my mind. What I saw was an interesting, fun product. Who doesn't want to work on a fun product? And then also the innovation. I mean, clearly, if these guys are building electric cars, there's going to be a huge amount of innovation.
What was your role there?
So during the interview process, I was asked a question that I had not prepared for. The guy who interviewed me, David Cross, asked me, do you want to work in the U.S. or do you want to work in Asia? And I paused for a few seconds and I said, Asia sounds fun.
Just that one simple question.
Yep, changed my whole life. So I was responsible for supplier development for Asian suppliers. We had another guy who was responsible for U.S. suppliers, third guy responsible for European suppliers. And each of us was responsible for any part of the car made in that geography. So that covered headlights, electronics, batteries, body panels. So it was a really, really wide-ranging job.
You were a senior supply development engineer, was your official title at Tesla at that time.
That's what the title said, but the supplier development job was unlike supplier development at any other company. In 2007, Tesla did not have their choice of suppliers. Automotive suppliers were not interested in selling this low volume of parts for their first car. It was just 2,000 cars. The regular automotive suppliers were set up to manufacture 30,000 parts a year. And they're also risk averse. They don't want to take on a project for a new startup when they have to turn down a project for, Mercedes or BMW or Ford or Toyota. Automotive suppliers had no interest in selling to a startup car company that's going to build an electric car.
Which was totally unthinkable at the time.
It was unthinkable. I had done a little research, and there were something like 100 car companies that had gone bankrupt in the U.S. since the last successful car company.
Odds against you?
Odds were completely against us. It was a small team. The management team didn't have experience in the automotive industry, and we're building this impossible product. We were working with suppliers that virtually had no experience in the automotive industry, particularly the Asian suppliers that I worked with.
And is this how you came to Taiwan?
This is how I ended up coming to Taiwan. We sourced a large number of components from Taiwan initially for the first car. We even set up a small manufacturing facility in Linkou for manufacturing motors that was open for about 2 years. We even expanded our supply chain in Taiwan. So that's one of the main reasons Tesla has such a large footprint of suppliers in Taiwan.
So we're talking about the Tesla Roadster here, and 30 to 40% of the Roadster has components that come from Taiwan. That sounds like a big number. And is there something about Taiwan that led to this high percentage of components?
So for the Roadster, we're looking to build about 2,000, 2,500 cars. And so that volume was a volume that Taiwanese suppliers were willing to take on. When we looked at Chinese suppliers, they were typically wanting to do much higher volumes, 20, 30,000 parts a year. Taiwan was a good match for Tesla in the very, very early days. The other part was the management structures of the Taiwanese companies tends to be pretty flat. You tend to have a boss and not many layers of management. What that allowed us to do is it allowed our supply chain team to talk directly to the ownership and able to convince them of kind of the strength of our project, but also convince them that they would have the ability to make the components we needed.
Because you couldn't get regular automotive suppliers to work with you, so you had to kind of think creatively? How did that work?
You know, we were building and designing parts that had never been seen before because they were for electric cars, and this technology just didn't exist. So our conversations would start with a lot of explanation. This is what we need. And then what I needed to do quite a bit is, this is why you could make it. I would have to convince the companies that we've already examined their capabilities and we know that they could transition their technology to make the parts that we needed, even though they didn't make anything that looked the same.
Do you have any fun stories about a particular component that you helped develop in Taiwan?
Yes, part of the cooling system for the battery, we had a really hard time kind of sourcing these components. We were able to find a supplier here in Taiwan that was able to make those parts, but they had no automotive experience before.
What did they make previously?
They typically made piping and tubing for like laboratories and chemistry labs and like scientific facilities. So that was a really difficult bring up for them to kind of understand the automotive quality, but we were able to get them to produce the parts for the first car.
Does the Model S still have 30 to 40% of its components made in Taiwan?
There's still a few suppliers that are providing full production parts to Tesla, but that number has dropped for some structural reasons. One is that Taiwan has a higher cost than China. The volumes have gotten high enough that Chinese suppliers are very interested in making these parts now where they weren't initially. In addition, Tesla has a manufacturing site in Shanghai, and so it just makes sense to make the parts close to your manufacturing site. Taiwan has a little bit of an obstacle in that everything in Taiwan is imported and exported. So there's always kind of this extra cost on it. And so unfortunately, many Taiwanese suppliers have lost their supply to Tesla as the company has grown and the volume has grown and the parts have become more of a commodity as opposed to a specialty.
Is this something that people should be concerned about for manufacturing in Taiwan in general, or is this just like a time and a place thing?
Well, some people certainly should be concerned about it. I found it as an opportunity. As the company grew, the number of people doing my job grew. We got to be a bit more specialized. The job became more interesting, but the pressure was ramping up because the volume and the cost and kind of the debt of the company was starting to get really big. So our need to be successful on the Model S meant we were really extended. There was no opportunity for us to allow this project to fail and us to keep our jobs. So the pressure was extremely high. That didn't bother me so much because, again, my suppliers are getting more and more professional. But also the number of companies I needed to handle grew drastically. My last full-time year at Tesla, I had about 100 flights a year.
Wow. Is that what made you want to leave Tesla ultimately? What was your motivation for wanting to move on?
You know, the motivation was a combination of factors. Probably the biggest one was my experience working outside the U.S. You know, my time at Tesla was my first time working outside of the U.S., and I noticed a different atmosphere. Over time, I began to understand that it was due to my race. And so this was my first time being treated without racism, being treated as an American, and working kind of without the prejudice of the people I was working around. And so I enjoyed that. I didn't necessarily want to work in the U.S. after that.
All right, let's take a break here. We've been talking to Azizi Tucker on how, upon leaving NASA, he became the supply chain guy for Tesla, which brought him out to Asia. And when we come back, we'll find out how Azizi set up his own electric vehicle company right here in Taiwan. Hey, did you like our new theme tune? For those in Taiwan, you'd recognize that as a remix of the Garbage Truck song. And I didn't make it. Spoiler alert. There's a team. There's a team working on this show. We have producers, music people, editors. And to support that team, we need money, unfortunately. And the best way to support the show is to go to patreon.com/wastenotwhynot and set up monthly donations. There's also member benefits. You can suggest ideas for the show and talk with us. So going down to patreon.com/wastenotwhynot and become a monthly donator today. Welcome back to Waste Not, Why Not. We've been talking to entrepreneur Azizi Tucker, one of the first 100 employees at Tesla and who had a heavy hand in figuring out its supply chain in Asia. Azizi realized that Taiwan was the perfect place for manufacturing and R&D. After leaving Tesla, he made the permanent move to Taiwan. Remember earlier, Azizi and I talked about him building the Tesla Roadster? I forgot to mention that the Roadster is a sports car, meaning it's designed to go fast. So what did Azizi do after he moved to Taiwan? He started to design electric, fast cars again, but this time he's building supercars, an electric supercar, which is like a super, super fast car, or so I'm told. This next invention would later become his company, Xing Mobility.
So from my time at Tesla, I really felt electric sports cars would be significant or could have a significant impact on kind of the automotive industry and could be an amazing product. So when we started the electric supercar project, I was not aware of anybody else building a car remotely close to what we were trying to achieve.
What was the top speed you were going for?
Not tremendously high, but the acceleration was insane. It was over 1,300 horsepower, so incredibly fast.
Okay. And this sports car you were designing, this was just a regular sports car?
Yes and no. We were designing a gasoline race car for racetrack use. And it's the first car I've ever designed from scratch. You know, it's a very special feeling to drive something you've designed that's, from scratch. So we built this car, but I did a little secret in the back in that while I designed the gasoline car, I designed a sister car that was electric. The gentleman I was working with at the time, he didn't have a lot of experience with electric cars like most people, so he didn't really understand it. But I met Royce Hong around the same time. And he was an early Tesla Roadster owner. So he understood the power and kind of the speed of electric cars. So once Royce joined the project, we transitioned to become Xing Mobility, and we quickly built that electric design that I had.
Pause that tape. Did you catch that name? Royce Hong, Azizi's co-founder for their Taiwanese company called Xing Mobility. Royce Hong comes from the world of product design. He had said in an interview that he met Azizi when they were both speakers at a TEDx event at Taipei. After the event, Azizi showed Royce the race car he was building at the time. And that's how Royce became the designer to the engineer that is Azizi. Together, they started building electric supercars. But they quickly ran into problems. They had trouble finding battery packs for their electric cars because nobody made them or thought to make them. But as I'm sure you picked up by now, Azizi has a way of turning challenges into opportunities.
So we thought we could just buy a battery pack. As we went shopping, I was appalled at the quality that was available. Actually, very few companies were interested in selling battery packs for low volume applications. And so through that challenge or that scarcity, we actually found an opportunity. So we realized, wait, there's lots of other commercial vehicles that are low volume that will need battery packs in the future. Whether it's an ambulance, a fire truck, construction machines, boats, buses, all of these companies are going to face the same challenge we faced trying to find this battery for our electric race car. And so that led us to develop our own battery system.
So in trying to solve these problems that batteries face, you accidentally sort of discovered that this was an opportunity for non-normal cars?
Yeah, non-passenger cars.
Non-passenger cars.
When we looked at the numbers in detail, we saw that actually only about 33% of engines in the world go into passenger cars, and about 66% go into other stuff. Ships, buses, construction machines, digging machines. And these vehicles actually are quite heavy polluters. So if you think about someone like Caterpillar, who makes the construction machines, they have hundreds of vehicles in their catalog, all different sizes and shapes. And so one of the things we thought about is how would you design drivetrain components for these companies? Because you can't just design a single battery pack. You need to design thousands of them potentially to match the size and shape for all these different vehicles. That led us to our patented Immersion Modular battery system, which kind of stacks up like Legos, and we're able to quickly design the batteries for different sizes and shaped vehicles.
And what's the connection between the drivetrain and the battery for people who might not be very knowledgeable about car design?
So when we talk about drivetrain, that's everything that makes the car move. For an electric car, that includes the batteries, the motors, what we call motor controllers, sometimes the gearbox.
So instead of making a Tesla excavator, you can just use like an Iron Man solution. Pull out the heart of one car and put it in EV heart.
Yep, that's it. So they didn't have experience manufacturing their own drivetrains. They were purchasing these drivetrains before. So we were setting Zing Mobility up to be the new electric drivetrain supplier for commercial and industrial vehicles. If you've spent any time in the city, you've seen diesel trucks idling while people are not in the vehicles. Or if you spent any time at a construction site, you've seen a dump truck with the engine running while people are loading it with dirt. So not only do we reduce the pollution through having it EV, we're turning the vehicles off when they're stationary, which has a massive reduction in energy used. There's huge potential for electric vehicles on the commercial and industrial side.
And is there any other benefits in terms of swapping out an engine with a battery? Is there a maintenance issue?
Yeah, surprisingly, the vehicles are getting less reliable every year due to more strict emissions. To meet the emissions regulations, they're adding a lot of new devices to commercial diesel engines. So moving to electric will simplify the vehicles vastly, allow them to apply the power in a much more efficient manner. And what I'm most excited about is multi-motor solutions, where you have a vehicle that has 5 or 6 motors right at the point where the power is needed, instead of having one massive diesel engine and shafts and gears running all over the place.
So it's not just about stopping pollution or climate change. It just sounds like it's better in some ways.
Better products, which is the thing that's always gotten me excited. Being environmentally conscious has been a theme of my career, but it's not been the driver. It's been about better products with a side effect being massively reduced pollution.
So you built an electric supercar, you built these electric drivetrains, this really important solution with batteries, and then you left again. What happened?
So I've left the company and have started Graft Electric Vehicles with a focus on recreational vehicles. So that's kind of the last piece of the pie that I haven't worked on that's electrified.
So we're coming back full circle, back to this tinkerer in Oakland. We're getting back into fun and how to electrify those types of vehicles.
Exactly. Throughout my career, I've been racing, and kind of the last racing I was doing was off-road racing, which is really not good for the environment. And so one of the things I was kind of focused on is using this electric drivetrains in a way to be better neighbors as we go off-road and do off-road recreation. So being electric, we have much less sound pollution. We obviously have much less CO2 pollution, and the vehicles are simply better.
And so for these recreational vehicles, what's the battery design like?
They need to be lightweight. They're swappable. We're using a solid-state monolith battery that's designed to be really lightweight. So the first vehicles that we're doing at Graft Electric Vehicles are an off-road motorcycle that'll be quickly followed up by our ATV, four-wheeler. And the batteries swap among all the vehicles we build. So one common battery can power all the vehicles.
And I think some people might be listening and think, oh, but batteries, I don't know if that's going to work for an ATV.
You know, with my history, I have a fairly good understanding of electric drivetrains, but also being someone who raced mountain bikes and raced cars and has raced in the Baja 1000, I know the environment well. And I'm able to engineer these battery systems to work really well in this environment. In fact, it's actually easier for me to design these vehicles than a gasoline vehicle because there's so many fewer components. Our motorcycle, for instance, has really only 3 major drivetrain components. We have a battery, a motor, and a motor controller. That's it. So you don't have a clutch, you don't have an air filter, you don't have oil pumps, fuel pumps, all these different things that you would have kind of hanging around a gasoline engine. We're really able to get the reliability through that.
Where do you make the bikes?
Yeah, so the bikes are quote unquote handmade, although we use a lot of computer and advanced machinery. So I don't know if handmade really counts. But each one is fully assembled in-house, but also we make a very large number of the components in-house. So we're starting with raw materials, blocks of aluminum, blocks of copper. We're laser cutting, we're CNC machining, and doing all the assembly and testing in-house.
So you just left Xing a couple months ago. What are you able to do by yourself or maybe with a small team? How does one man build an electric dirt bike company?
Well, I've worked in small companies, 30-people companies. At Tesla, we ran from about 100 people up to maybe 2,000 or more when I left. And obviously being in NASA Goddard is a very large organization. Xing is about 50 people. At Graft is obviously the smallest organization I've worked in. I just hired my first employee just 2 weeks ago. And so for the last 10 months, it's just been a one-man show. But what I'm able to do that's unique is I'm able to tie the design to the manufacturing completely together. It's not unusual for me to design a part in the morning, manufacture half of it, and realize I made a mistake in the design, and then update that design, and then finish making the part. There's no separate manufacturing group and separate design group. It's one person, in my case, allows me to be ultra efficient in the designs that I manufacture.
Wow. So what's a typical day look like?
Typical days are pretty fun. Typically, we'll get up in the morning, do some work on the website, kind of work on the ERP system and some of the back-end ordering stuff. And then in the morning, if it's a really good day, I might bring 3 vehicles for test rides. Afternoon, I'm evaluating the results of the test rides and manufacturing parts. And then repeat it all the next day with the new parts that I manufactured that day.
That sounds pretty good. That sounds like a schedule a lot of people would like to have.
It is. I mean, the local gas station, all the people are really jealous of me. They see me pull up with different motorcycles and ATVs kind of every third or fourth day. They can't figure out what I do for a living.
And you don't tell them just to have the mystery.
Not at all. Not at all.
So where do you test these dirt bikes? And are people ever confused at these just sort of silent things flying over hills?
For off-road vehicles, we're building a test track directly across the street from our workshop. So we just have the first half kilometer that is already dug. So we literally go out the street and we're right on the trail. In addition, there's a local racetrack built by the city. We also test in the mountains. We test in the beach because we need to test in a variety of different conditions. So whether it's snow, sand, high speed, low speed, muddy, fast terrain, we basically need to travel around and test in different locations. But when people do see the vehicles, typically they're amazed. My neighbors are still surprised every time I pull one out and, shoot up the hill silently past them. It is nice to see the reaction, particularly when I'm out on some of the trails of hikers and other trail users who are friendly. They're happy. I'm stopped on the side of the trail while they come past. Many of them don't even know I'm on a motorcycle and just assume it's a bicycle. And so that reaction from trail users has really been, kind of validation of what we're trying to do.
How fast do they go? When I was on it, I had no sense of speed. It was just pure adrenaline.
Yeah, so our first motorcycle will probably top out at around 80 kilometers an hour. It could go much faster, but we want to keep that explosive power for hill climbs and tricky off-road situations. So we're sacrificing just a little bit of top speed for really, really fast acceleration.
So why Taiwan for Graft? I mean, we know you like living in Taiwan.
One of the main reasons that Graft is here in Taiwan is the reason Tesla left. The majority of Tesla's supply chain is left to focus on high volume, low cost components. The thing that I noticed here in Taiwan and the reason I moved here was an incredible supply chain for low volume, high mix, flexibility, and especially for speed. When you visited me, we bought material, we made a part, and then we were riding in the same day. Taiwan is one of the few places in the world where you can do that.
Yeah, factory to workshop, 30-minute drive, easy to do.
Exactly. With my current motorcycle, I would say almost 75% of the components are sourced locally in Taiwan, from kind of the simplest nut, bolts, and screws down to the battery cells. But even specialized parts like tires are made local, 20 minutes away from my office, and allow us to be ultra rapid. In addition, it means that I have personal relationships with all of my suppliers.
Wow. So around 70% of the bike is made with components in Taiwan. Why don't more companies do this? Why don't more companies build with all these different Taiwanese pieces?
I don't know the answer to that. And this is kind of the secret I'm hesitant to share. But building a complex product in Taiwan is incredibly easy because you have such a density of supply chain that you will never see anywhere else in the world. Whether it's rubber parts, whether it's metal parts, whether it's electronics, I can visit all those suppliers in one day. I'm really surprised that there's so few companies here in Taiwan that are really leveraging the Taiwanese supply chain to build a complete product or system.
Well, designers come to Taiwan and start building.
Absolutely. It's an amazing place to be an engineer. The resources I have available at hand to bring my ideas to reality is just, it's mind-blowing.
And what's your goal with this company? Are we going to be able to buy your bikes anytime soon, or?
So the motorcycle will be available for order very, very soon. Actually, it'll be available for order by the time this podcast is produced. We have the ATV coming up next. That'll be available probably midsummer. After that is the buggy, and I think our next vehicle after that is going to be a small boat.
Oh, wow. Silent boat.
Yep. But my goal with the company is to grow our lineup pretty aggressively. We'll probably do one new vehicle every single year. So snowmobile, a jet ski, boat. So we'll kind of grow the company organically from there. And we may begin to also offer our powertrains to other companies.
Wow. So changing the whole recreational market.
Absolutely.
So what are some of the applications for this battery system you're developing? I mean, I've seen some places are starting to ban combustion leaf blowers. What else? What else could you use it for?
So, I mean, certainly landscape would be a major market. So you could see leaf blowers and lawn mowers. And my favorite is the snow blower that runs at 3 a.m, clearing your sidewalk.
This happens in snowy places?
Absolutely.
Okay.
Absolutely.
Okay, good to know.
Yeah, but also the small machines at construction sites, kind of the jackhammers and some of these tools could become electric. Particularly, here in Taiwan, we live in apartment buildings. Typically, you can hear the renovation work going on in other units. So our drive trains and power systems potentially could be used there.
Well, for my beauty sleep, I hope this innovation spreads in Taiwan and we can start to replace some of these tools with electric ones. So your career has taken a non-traditional path. It doesn't seem like there was really a book that you could have followed. There's no, this is how you design electric vehicles. This is how you design spacecraft. So what would be some advice you would give to young people who are considering, I want to get involved with electrification. I want to get involved with clean technology. How should they approach this?
Like a lot of new technologies, there's no classes or very few classes on electric vehicles. When I left the automotive industry, I have a lot of friends who worked in the industry. And I was quite nervous for what their careers would be like. But I would say probably 80 to 90% of those guys and women are now working on electric vehicles. As new technology comes in, as long as you're aggressive about learning the new technology in any way possible, whether that's professional education, whether it's hands-on, whether it's job training, or just new opportunities, typically you can find that you can transition to new technologies as they come along. Obviously, getting involved in kind of any project you can. Formula Student is a college opportunity, and there's several teams here in Taiwan where teams are building their own electric race cars. I just saw one 2 days ago that looked much, much better than the ones I had seen previously. And I was a little bit surprised to notice that here in Taiwan, the students have more experience in designing electric vehicles than the professional engineers. Because they're doing it as part of the student competition.
So just experimenting, trying new things.
Exactly.
So if we learn anything from your career, it's just keep learning. When there's new technology, follow it. Stay true to your passions, what you want to do. Don't be afraid to leave someplace, even if it's a big brand name. There's going to be more interesting things ahead. And get involved, try new things, because that's how you're going to discover these new technologies or new businesses.
Yep.
Thank you, Azizi, for coming in and talking to us about not just electric vehicles, not just your experience with designing electric vehicles, but your career. I think it's really valuable for young people to kind of hear how you've grown and changed and done all these different really amazing things. We don't get to often hear these perspectives, so thank you.
Thank you for letting me share. It's been fun.
Happy to. And hope to talk to you again as more vehicles come out and if you ever need a test driver.
I definitely will take you up on that.
Okay. All right. Thanks.
I think that's it.
Thanks to Azizi Tucker of Graft EV for talking to us about his passion and career path. If you want to keep up to date on the electric dirt bikes he's building, Graft EV has a good-looking Instagram page at Graft Electric Vehicles. Also, there's a link in the show notes. That's it today. Thanks again for listening all the way to the end. In the next episode, we're going to learn about solar energy and money. I only know about one of those things. I'm Nature Nate. This is Waste Not, Why Not, a Ghost Island media production based in Taipei, Taiwan. Emily Y. Wu is our producer and story editor. Yu Chun is our audio editor. Gerald Williams is our intern. Paul Chu at Gazing Element filmed our field day at Azizi's workshop. Video sizzle reel edited by Chu Wei. This episode was done in collaboration with the American Institute in Taiwan. Thanks for listening. Bye-bye. Bye-bye.